When you're trying to solve system of equations, there are times when you're going to end up with no solution as an answer, and there are times when you're going to end up with there's infinitely many solutions as your answer. Graphically, a no solution problem would look like parallel lines. So if you were to be asked to solve this system of equations, the way that they chose to do it was to use elimination. You could have also easily gotten this y by itself and used substitution. But through elimination, they ended up getting the 4's to eliminate. So we multiplied everything in the bottom one by -2. When the 4's eliminated, the 2's also eliminated at the exact same time. So you end up with 0 plus 0 equals -6. And then you end up with 0 equals -6. Well, 0 doesn't equal -6. That doesn't make any sense. It's not possible. So there's no solution. So one way to check and see if just to check your work is to graph the two lines, because when you graph two lines that have no solution, that means they're never ever going to touch. There's only one way that two lines will never touch, and that is if they are parallel lines. And this is what parallel lines look like. They have the exact same slope, but they cross the y-intercept in different places, or the y-axis in different places. They have different y-intercepts. So these two lines will never touch. No solution is the only possible answer for this one. Likewise, there's also the case of infinitely many solutions. So what that would look like if you were solving that using substitution. This y is already by itself, so it's really set up nicely for substitution. You just plug this piece of information right here into the y. And when you do that, what happens is your 3x and your other 3x, or your negative 3x, they cancel out to 0. So you're left with 4 on this side and 4 on that side. So 0 plus 4 equals 4. So 4 does in fact equal 4. Well, 4 is always going to equal 4. No matter what you do, that equation is always going to be true. It wouldn't have mattered what I plugged in for x. I could have plugged in 1,000,000 for x. And what's going to happen is you're going to end up with 4 equals 4. So again, to check your work, you could graph the two lines, and what happens is you end up graphing the exact same line. In fact, if you just subtracted the 3x from both sides over here, you would see that they would be the exact same y equals mx plus b formula of 4 minus 3x. So that's how you end up with the exact same line, or infinitely many solutions. Every solution on that line counts. So solve each system of linear equations algebraically. So if we were going to use, because this y is already totally by itself, I would use substitution. So I'm going to plug 3x in for this y right here. And we're going to say 2 times 3x equals 6x. Well, 2 times 3 is 6, so 6x equals 6x. Well, no matter what I plug in for x, when I multiply that number by 6 on both sides, I'm going to always end up with the same number. So if I plugged in 0, if I let x equal 0, and 6 times 0 equals 6 times 0. Well, that just makes sense. So this is infinitely many solutions. So infinitely many solutions. You may have also seen me draw the symbol for infinity, which looks like a sideways 8. You could write that as well. Alright, so here's another example that would be really great for substitution. We're just going to plug that in right here for this y, since the first y is already by itself. So when I plug in 2x plus 5 minus 2x equals 1. Well, 2x minus 2x is 0, so 0 plus 5 equals 1, or 5 equals 1. Well, 5 doesn't equal 1. 5 never equals 1 under any circumstances. So this is going to be no solution. Alright, and if we take a look at this one, substitution doesn't work really well because none of the letters are by themselves. I wouldn't want to graph either of them either because the y's aren't by themselves already. So I'm going to multiply this top piece here by 2 so that my x's will cancel out. So I'm going to multiply it in, and I'm going to write my answers just below it that I get when I multiply. So this becomes 6x, and then 2 times negative 2 is minus 4y, and then 2 times 9 equals 18. I'm going to draw my line. I'm going to add them straight down. So negative 6x plus 6x is 0. Positive 4 minus 4 is 0 equals, and then 1 plus 18 is 19. So 0 equals 19. Well, 0 does not equal 19. It will never equal 19. So the only possible answer is no solution. Something we really didn't talk much about at all was consistent, independent, consistent, dependent, inconsistent, no solution, same slope. So if we take a look right here, a system of linear equations can be classified in 3 ways. It can be considered consistent and independent, which means they have exactly one solution and the 2 lines have different slopes. In order to have one solution, they have to cross. The only way they can cross is if they have different slopes. Consistent and dependent are infinitely many solutions. So that means they are consistent in that they move in the same direction. They have the exact same slope, the exact same y-intercepts. So when it's consistent and dependent, the lines depend on each other. They're the exact same line. And then consistent no solutions means they're going to have the same slope but different y-intercepts. So what we would get for an example of that would be 2 lines that there would be no solution for. So if we took a look here and classified, I see that they have the exact same slope, but they have different y-intercepts. So that would be inconsistent and that's it. They're never going to touch. So there's no independent or dependent. They are not consistent. It's not going to touch. These 2 here have the same slope of positive 2. Whoops, sorry. Same slope of positive 2. Same y-intercept of plus 5. So if they have the same slope and the same y-intercept, they are consistent and dependent. Alright, if we take a look at this one, these 2 would have the exact same slope. Actually, I believe this goes up here. This picture goes up here. This goes right there. When I moved things around so I could copy them for us, it messed up a little bit. So we can't see this one, so we're going to cross out 6 because we can't do that problem. Let's take a look at these. Classify each problem and get the number of solutions. So right here we take a look. They have, if I added 4x to either side so that I get the y by itself, I would get y equals 4x plus 8. So these 2 here have different slopes. So they're going to be consistent. And they're going to have one solution. They have different slopes. Because they have the same y-intercept, it just means that their solution is going to be at the y-intercept. But it's just still the one solution. If we take a look at these 2, I'd want to get y by itself in both cases. So I'm going to add the 2 and subtract the 3x. So I'm going to get y plus 3x equals 2 because I added 2 to both sides. And I'm going to subtract 3x. So I'm going to get y equals negative 3x plus 2. So that's one equation. And then my other equation is I'm going to subtract the 9x. So I get 3y equals negative 9x plus 6. I'm going to divide everything by 3 so that I get the y totally by itself. So that's y equals negative 3x, and then 3 into 6 is plus 2. Well, these 2, when I compare them, they have the same slope and they have the exact same y-intercept. So I look back up at my chart and I see that means they are consistent and dependent. I have the review sheets and wanted you to have this information, but this piece will not be on your test for the cumulative test because we didn't learn it in the beginning.